Well, good evening, everyone. Thanks for making it out tonight. It's one of those squirrely sorts of nights. This evening we've got Phill, VK3VC, presenting via Zoom on the early history of the nuclear program in the States. I'll hand over to Phill, who is going to present this evening on the early nuclear program from Northern Victoria. Thank you.
All right, I suppose we should be sharing a screen. This talk was originally given to the University of the Third Age up here. It was designed to run over about an hour and a half. So I will probably be trimming things, and you may see me skip over a slide or two that are deemed unnecessary, so we don't keep you up here all night. But that's the background. The story goes that I've had a bit of a lifelong fascination with atomic testing, and I've really followed what went on. I've actually been to Nevada, to the test site there. I've been to the early Trinity test site in Alamogordo, Los Alamos, and quite a few places, and you'll probably see a few family snapshots a bit later as we go on. I'll try and keep them short, and I will watch the time, and as we get closer to 9 o'clock I'll be zooming through slides. So the story goes that when I was young, and I was born in 1949, so I missed the early atomic testing, well, at least the first test and the Nagasaki and Hiroshima, but there was daily, well, almost daily, weekly photos of the atomic mushroom clouds in the headlines of the papers, and one here that I noticed that I read after I'd actually cut and pasted the thing here. The scientist says atomic test cleared as clean by the committee. I don't know whether you can read any of this, but it says Professor Martin said all dangerous fallout has been deposited, where he doesn't say, and the remaining fallout was innocuous. So does that make you feel any safer if you were... this was in Australia, by the way. This was the Maralinga test. So not a nice place to be. And if you really want to scare yourself, have a look at some of the fallout maps of where the Maralinga and Montebello Island tests dropped their clouds, so or dropped the fallout. Went through childhood hearing names like Marshall Islands, Bikini Atoll, Mururoa Atoll, Maralinga, and so on, and code names like Able, Baker, Operation Crossroads, Ivy, Mike, and all things that we were familiar to as in my childhood anyway. And I'd like to put together a bit to show you how reckless and cavalier I thought they were with their testing. Try and show you a bit about how to build your own atomic bomb. The very early days, we had J.J. Thomson found the electron in 1897. So that time from the late 1800s to the early 1900s was a busy time. Madame Eve Curie discovered radium. Max Planck arrived at his quantum theory. Einstein did his things in 1905, E equals MC squared. Heisenberg, Schrödinger, all the names that you'll know. Jean Lautrec, Julio Curie, and his wife produced artificial radioactivity. Don't know how you do that. And in 1938, Enrico Fermi won the Nobel Prize for experimenting with slow neutron bombardment. At that time, most of the stuff was being done at the major European universities, Cambridge, Leiden, Copenhagen, and a little bit in America, but mostly European universities. And with the rise of fascism in Hungary and Germany and Italy, they became a lot of anti-Semitic stuff went on, and Mussolini attacks on the Jewish physics. A stream of immigrants from Europe to America, 20 to 25,000 of these people in every field ended up in America, and one amongst them was Albert Einstein and Enrico Fermi. In 1938, the German chemists Otto Hahn and Fritz Strassmann were bombarding uranium with neutrons. Now, I don't know where you get a bag of neutrons and where you how you bombard them, but I know it does require very high voltages, and they used a Crockford-Walton generator you may have heard of to generate very high voltages and slam these neutrons into their sample, and they found after their testing that there was barium and krypton in their experiments, and they couldn't quite work this out, but they did write a letter to their assistant Lise Meitner, who'd escaped Germany and gone to Sweden, and she was able to put it all together and find that barium was about half the atomic weight of uranium, and they'd actually split the atom. And Meitner discussed it with a nephew, Otto Frisch, who was working with Niels Bohr, and Frisch told him to about it just as he was leaving for a conference in Washington, D.C. And on January 27th, 1939, our friend Niels Bohr announced the discovery to the conference of astonished physicists. They all raced back to their laboratories and tried to reproduce the experiment, and with some success. So here we have Lise Meitner, Otto Strassmann and Hahn, and Lise Meitner doesn't get a lot of credit for all of this, although she is now known as the mother of the atomic bomb. So that's her. This is the process that happens if you slam a spare neutron into a uranium atom. You get out, you break it up, and you get krypton formed and barium formed, and 3 more neutrons coming out. And if those neutrons hit another one, you get 3 more and 3 more, and so on, until you can have a chain reaction. And you're probably aware of what a chain reaction is, but here's a demonstration from Berkeley where they drop 1 neutron in and start off all these mousetraps busily firing away. And that's the principle of a chain reaction, basically. The next thing that they needed to know, or you need to know before you make your atomic bomb, is what is critical mass. These slides are from Los Alamos at the time, and on the left over here is little blocks of uranium that they were building up, a lot of other tamper material to sort of stop it from going off, lots of test gear to monitor, and very carefully putting a little block more to find out what point you've got too much and it's going to go bang. And they called this process tickling the dragon's tail. And so that's what they had to do, was they had to get closer and closer to before it finally does go critical. and there's 2 people at least were killed in these criticality experiments that they were trying to make, trying to get to that point. On the right over here is a ball of plutonium, which would be about the critical mass, or not quite the critical mass of plutonium. We'll talk about that a bit later. And Albert Einstein was approached by Leo Szilard, Eugene Winger, and Edward Teller, and asked whether, well, explained to him that the Germans seemed to be working on atomic energy, and that hoped that he would write to President Roosevelt and ask him to put some effort into working on atomic energy in America. And this is the famous Einstein letter that you'll hear referred to quite often. And he sent it off with a friend who delivered it to Roosevelt, and Roosevelt finally agreed to do something about it. And what do? You form a committee, and the committee did very little. But what did happen was that this Colonel James C. Martin was initially appointed to head the project. It was later taken over by Groves. But the British Maud Committee produced a report suggesting a time frame for constructing a bomb and the costings. There was still not a lot of movement till after Pearl Harbor, when the British delegation visited again. Things finally got moving. And General Leslie Groves is the man that was credited with building the Pentagon, would you believe? He supervised the construction of the Pentagon, and it was coming to an end about this time, and he was very keen to get off and get into the fighting war, as it was, so he could. He knew that all the promotions came from being out on fighting a war sort of thing, so he was very keen to head out and be in the fighting war, and he'd actually been offered a position out there. Went to his commanding officer and asked if he could take that position, and his boss said, "No, I've got another job for you. I want you to do this, and if you do it properly, you'll end the war." Groves was not at all impressed. He didn't want to work with a whole bunch of, as he put it, crackpots, but he warmed to the job. And as you'll read, I'll put a couple of books up at the end of this, that he had his finger in every pie. He was involved in absolutely everything. And even after Germany was retreating, he had a team over there following the German scientists or rounding up the German scientists that they knew, and that was the thing, that they knew all their names, they knew where they studied, where they worked, and he had a team over there. So he was a very busy man during the 3-4 years that the Americans were involved in the war. And of course, Robert Oppenheimer was an unlikely candidate to head the scientific side of the development. He had never actually run a team of scientists before, and he was thought unlikely to do that. But Groves had faith in him, and he went ahead and did it. There was a lot of argument as to how Oppenheimer wanted to keep it like a university where everyone from every department could stick their head in and talk about what was going on. And Groves said, no, it's got to be all compartmentalised, and you can't do that. But they settled on a weekly meeting where they would give progress reports, and if anyone had any great ideas that they could present them at that time. What they needed was uranium or uranium oxide. And you need an awful lot of uranium because uranium-235, which is the, as they call the fissionable section of uranium that you can split it, only occurs something like a very small percentage of the total weight of the uranium. They realised they would need uranium. There were some uranium mined in Canada and some in America as well, but it wasn't very high quality. And the best quality uranium came from a mine in the Belgian Congo. But with Belgium being under German control by this time, the mine manager had made contact with the only board member who wasn't in Belgium or in jail, and he was in the UK, and made contact with him, and he introduced him to a scientist who told him that this uranium is going to become valuable. You should pack up all your stock you've got there and ship it to the UK. Well, he didn't actually do that. He packed it up and shipped it to the US instead, and they had a stockpile of 1,200 tons of uranium oxide on Long Island. So when they did come to ask for uranium, yes, we've got it here and we've got it on Long Island. So it was very fortuitous to the Americans and their project. The use of uranium up until that point was primarily two things. One was for radium, but again, about 1/7 of a gram per ton of uranium is radium, and the other use was for a colouring in clay for making chinaware. So it really wasn't seen as very valuable, but the Americans actually got the mine manager to go back to the Belgian Congo and reopen the mine and start shipping uranium, and they were getting about 400 tons a month shipped to America from the mine, which they needed every bit of it as they went along. Now, in December 1942, our friend Enrico Fermi put together a pile of blocks of pure carbon in the form of graphite and stacked it with 500 tons of graphite, 50 tons of uranium oxide, and created the first atomic pile. And it's called a pile because that's what it was. It was a pile of bricks of graphite. Now, there are no photos. The photo on the left is the only photo that looks nothing like this drawing on the right. Security reasons said that they couldn't take photos, and so someone made a drawing of it. You can find photos of a model of it, but no photos of it. And this was where they made the first controlled nuclear reaction, controlled first sustained nuclear reaction. And they slowly pulled out the cadmium rods. You see the guy down here pulling out a cadmium rod. They were watching all their instruments and listening to the counters go off as they slowly pulled it out until they had a sustained reaction that made all of, I think, 5 watts or something like that was the the total energy output from it. But they had a bunch of people that were up on the top here with buckets of cadmium liquid, and they were the suicide squad. If anything went wrong, they were to throw this liquid cadmium into the pile and hopefully stop any reaction. So that's the first one, and that Chicago pile was later disassembled and moved to Hanford, where they did the processing of plutonium, which we'll talk about in a minute. So apart from uranium-235, which we said is in very small quantities in a sample of uranium-238, they needed plutonium as well. Now, plutonium doesn't occur naturally. It's a byproduct of uranium fission, where they split the uranium atoms, and they decided to set up two processing plants, one at Hanford in Washington State to make plutonium, and at Oak Ridge in Tennessee to separate uranium-238 of 235 from 238. And they searched for places to do this. They finally settled on the Hanford and Oak Ridge, and they were also looking for their laboratories. Oppenheimer's parents had a ranch near Los Alamos, and he'd spent a lot of time as his childhood horse riding and things in the area. So they finally went and had a look at Los Alamos and settled on that. Just to give you an idea where Oak Ridge is in Tennessee, it's very close to Fort Knox at Knoxfield in Tennessee, Hanford up on the river up here in Washington, both close to railway lines and rivers. So they had plenty of cooling water to cool their processes, and they could move stuff to and from and back to Los Alamos as they went along. And in making these big plants, Groves realised that the army didn't have the resources to make these massive factories that were needed, and they brought in people like DuPont, who you'll know DuPont from Teflon, and before that nylon. Chrysler, Alice Chalmers as a farming machinery, tractors and such manufacturer. Chrysler was asked to build one of the plants at Oak Ridge. They actually were a bit reluctant to do so in the first place because the whole process had never been tested in any scale. Universities had been breaking down uranium 238 into 235 in small scale processes, and Chrysler was asked to build this huge factory to do it, and it had never been done. So they were reluctant initially to do it, but ultimately they quoted $1 to manage the process, obviously cost plus, and that plus was $1 sort of thing. That went on, and Chrysler was ultimately paid their $1 at the end of the war, until some accountant noted that there was also a time clause on the contract and they hadn't expired, so they asked for 33 cents back. There's a picture of Oak Ridge, and you can see the size of the city that they built. They had thousands of employees, big plants, didn't have time to build roads a lot of the time. the people would drive to the nearest town, which was Knoxfield, and the locals could tell them immediately, because their car had mud all up the side of them, and people had mud on their shoes, and they knew these were foreigners from Oak Ridge who would never say what they were doing for over there. And this is one of the plants that Chrysler built. One of the three processes for separating uranium-235 from uranium-238 is called gaseous diffusion, where you heat it up into a gas and force it through a very fine filter. The thing about uranium-235 and 238 is that they are very close, as you can see by the atomic numbers. They weigh roughly the same. 235 is slightly lighter. They're chemically very similar, and there ain't a lot between them to separate the two. And so they built not one but three plants for three processes. They didn't know which one would work, and they had this gaseous diffusion. There was an electromagnetic process, and there was also a thermal diffusion, which needed lots of heat and steam also to do that. So that's the sort of things, and this all went on in the space of 3 years, basically, towards the end of the war. Electromagnetic separation, you're a bit more familiar with a cyclotron, and this was called a calutron. The guy that invented the cyclotron invented this, and it's got huge electromagnets all the way around it, and the lighter particles get deflected by the magnets and go around the racetrack, as they called it. The heavier particles get thrown out so they can separate 235 from 238. And there was a total of 92 of these calutrons. And here's the girls, the calutron girls as they were known, sitting at their mass spectrometers monitoring the process on these calutrons. Now, this required an awful lot of copper, and copper was in short supply during the war, as seen by these steel pennies, 1 cent pieces, that they made for 43 to 45. And it was hard to get copper to make the big transformers for the calutrons, or the big electromagnets for the calutrons. So Oppenheimer went to the US bullion depository at West Point and requested 14,000 tons of silver, took it to the copper wire manufacturer and said, "Here, please make us some silver wire out of this." So as you all know, silver is a very good conductor, probably better than copper. Did that. They went back and got another 268,000 pounds to make flat bus bars, got their transformers. The deal was that he would borrow this for the duration of the war or the project, and he did return it, and there was very little lost along the way due to shrinkage or otherwise. So that was the thing. The other plant, as we said, was Hanford in Washington State. And you can see the river in the background there, that they had plenty of water for steam and things. And again, another huge city was built up around there, thousands of employees. That was to separate, to produce plutonium. And they started with the atomic pile from Chicago. They built another one. They built a water-based reactor as well, and had to keep them all fairly well separated over a lot of area, just in case something went wrong. You may have heard deuterium, heavy water. And the Germans apparently in their atomic programs started out with the same idea as the Americans, getting blocks of carbon, pure carbon or graphite, and using that as their material to absorb the radiation, and didn't have a great deal of success with it because the carbon had a lot of impurities in it. So they dropped that idea altogether and decided to go with heavy water, which is the other good way of absorbing the radiation. They concentrated on a heavy water production up in Norway. You may have heard, it'll only be old people like me have heard of a movie called, it's a World War II commando raid on the Norsk hydro plant in the Telemark region of Norway, and they got in and they blew up the heavy water production facilities at this hydro plant. And that, for me, answered some questions that I'd had since I'd seen the movie. What the hell do they need heavy water for? Well, the Americans didn't need it as much as the Germans did. Destroy the plant and sunk a ship carrying water across the fjord as well. So that cut the German production of heavy water or deuterium. Now, Los Alamos, the only buildings at Los Alamos at the time was this boys' school, and they approached the boys' school about taking over the site, and the owners of the school were rather keen to sell because they had financial difficulties, and decided that they'd be happy to sell to the army for their uses. And so there's some pictures of the technical area during 1943 or 4, I think that photo is. It's a flat area on top of a big mesa. Over here is the main gate, which is a pretty famous photo of what you'll see at the new arrivals to Los Alamos were all sent by train to Santa Fe, which is down the hill on the flat from Los Alamos, and they were told to report to 109 East Palace, Santa Fe, and someone there would meet them. If their paperwork checked out all right, they were put on a bus up the hill, as it was referred to. From then on, any contact with them was always a post office box in Santa Fe. So post office box 1663 Santa Fe was all their mail, ingoing and outgoing, and in fact even birth certificates for the some 200 odd children that were born to scientists and their wives at Santa Fe over the period of the war, or period of the construction of the bomb, were all shown on their birth certificates as being born at post office box 1663 Santa Fe. How do you make a bomb? If you've got your uranium separated, your uranium-235, and you know what makes a critical mass, you basically put half of your critical mass at one end of a gun barrel effectively, and you put the other half of your critical mass at this end of it, and just fire off a propellant and slam the two together, and bang, you've got an explosion. All really fairly simple and fairly easier. So that's easy for uranium. But for plutonium, it worked out a little different. They decided that that plutonium, the two halves needed to be further apart, And this is a real gun barrel, a real artillery piece that they set up. And even before they made any attempt to use it, they worked out that it just wasn't going to work, that the plutonium started to react far too soon as the two halves came together. The gun barrel technique was never going to work for plutonium. However, they really had to keep working on the project. So even while they were making up their mind that it was going to work or wasn't going to work, they went ahead and they made dummy bombs. They took them out and dropped them as test bomb. They modified the aircraft bomb bays to be able to take them on the assumption it would happen. And the whole project, if you read particularly General Grove's report of the project, all this stuff was happening so fast that they just had to keep pushing and going ahead. One of the things that while they were uncertain whether it would work, let's go back to that one, they thought, what if it doesn't work? And we end up simply having a bit of a fizzer of an explosion, and we blow all our incredibly expensive plutonium all over the place. We need some sort of containment vessel to hold it into. And hence we have Jumbo. Jumbo was a 214-ton steel casting. They went and spent $2 million to find a steelworks that could cast a job of this size. Although I've never seen it written anywhere, it's pretty obvious that it was designed for the gun barrel bomb, because when you see photos of the gadget, the Trinity bomb, there's no way it would have fitted in there. You'd be like building a ship in a bottle. You'd have to feed the parts through and build it up inside. So I believe that Jumbo was designed for the gun barrel bomb that never happened. What happened was that when they actually let the bomb off, they built this tower close by and hoisted Jumbo up, pretty much in the hope that Jumbo would go away, but it didn't. And that was the story. Now, we come to the actual test. It was called Trinity, and there's a lot of theories around as to why it was called Trinity. The nearest rail crossing to Trinity was actually a place called Pope's Crossing, and someone reportedly said that, well, it'll need more than the Pope to get this bomb to the site. We'll need the whole Holy Trinity to get it there. There's another theory that Oppenheimer was reading a book by a poet. He actually refers to the Trinity in the book. That doesn't really ring true, because Oppenheimer, would you believe, taught himself to read Sanskrit and read the ancient Hindu scriptures in the original Sanskrit, and he would be more likely referring to the Holy Trinity of the Hindu scriptures. So that was Trinity. Now, it was supposed to be 214 tons. It was supposed to be 10-foot diameter. It was supposed to have 15-inch thick walls. I've seen Jumbo because it survived the atomic blast. Groves was quite worried that some accountant would knock on his door and say, "Why did you spend $2 million on this thing and haven't used it? It's just sitting there." So he had it loaded up with conventional explosives and basically blew the ends off it. Now this is where the family photos come in. This is my wife and daughter at the Trinity site, and this is what's left of Jumbo. Now, I had my daughter put her hand up there, and you can see her look at me saying, "Dad, why am I doing this?" Well, I said, "Put your hand up there, and anyone can see that ain't 15 inches." So I think they were robbed. So after they decided that the gun barrel wasn't going to work, they decided the only way to do it was to get a subcritical ball of plutonium, which we saw in the photo earlier, subject it to a massive conventional explosive from all sides, and compress it down till it reaches criticality and goes bang. And they brought in lots of explosive experts to find ways to do this. They moulded explosives into triangular sections and packed it around the bomb. Right up to the time of the actual test, they had some doubts that it would work. So this is how an implosion bomb works. You've got all these sectors of explosive material. Each one of them's got its own detonator, and you've got to try and get them all to go bang at the same time and compress it down until it explodes. And this was one of the many explosion experiments that they did, trying to get balls to compress. Now, the B-29 Super Fortress was the aircraft at the time that was being used in Europe and in Asia. And Groves put in a request for 20, would you believe, B-29 bombers, because he figured that they had 2, possibly 3 bombs to drop on the Japanese, and that they would need that many aircraft to have not only the main bomb dropping aircraft, but support aircraft and observational stuff. So he went and requested 20 B-29 bombers and was given 20 B-29 bombers. They weren't all brand new. They were mostly been back to the factory for reconditioning, and they used those. He put together a squadron with Colonel Tibbett that we know about, that flew the Enola Gay. He had these men practicing dropping dummy bombs, doing mostly navigation exercises, because when they were flying under big formations in Europe, they would generally only have 1 or 2 master navigators that would control the whole flight. And the other navigators just had to have enough knowledge to get back to England on their own if they got separated from the group. So there was a lot of intensive navigation training going, and they flew out to the Caribbean, did a lot of that. Now, come the time we were getting closer to the actual bomb, Tibbett reported to Groves that these aircraft had done an awful lot of hours, and the engines were getting tired, and they needed some new ones. So Groves was able to go back and request another. I think he only got 8 or 10 this time. Yeah, I haven't got the number there, but there was about 8 or 10 that they gave him brand new ones this time. And of course, the Air Force was very keen to be seen to be helping, so that they didn't let the side down and didn't the bomb didn't get dropped because of them. So that was it. They looked for somewhere to let off the bomb, and they settled on the Alamogordo bombing range, 120 miles south of Albuquerque, and about 30 miles from Los Alamos, 300 miles from Los Alamos. Lots of theories as to why it was called Trinity, and we talked about that. Here it is, the Trinity test site. It's now the White Sands Missile Range. So there's Albuquerque, San Antonio, and you come in this way. It doesn't show Los Alamos up here, but that's it. And that's a view out across the towards the Oscura Mountains in the distance. Having seen lots of these photos, it was fascinating to actually visit the site and actually stand there and see the world. Now, before they set off the bomb, they decided they really had to calibrate all their instruments, and they put together 100 tons of TNT. They had a local contractor doing some work for them, and they were doing 3 weeks on, 1 week off type work. In the 3 weeks on, they built this huge stand to hold 100 tons of TNT. They went away for their 1 week off and came back the next week, and the stand was all gone as they'd blown it up with their test. The test date, as the test date got closer, Groves requested the Army's best weather forecaster. I don't think he listened to him, because he was told that the days not to use were the 16th and 17th of July. They went to, or the forecaster went around the scientists and asked for the best conditions they could expect. But Groves was under pressure to report to Truman at the Potsdam Conference with Stalin and Churchill. He decided it was going to be done on the 16th of July, come rain or shine. Just a photo there of them delivering the plutonium core to be assembled. They assembled it at the what's known as the McDonald's Ranch, which is close to the site. It was about the only structure that was permanent structure close to the site. The bomb itself, or the gadget, they were always all told to call it a gadget, not to call it a bomb. Top of the tower there, and you can see wires everywhere. The bomb ring raised up the tower. Someone raced out and got some mattresses to put underneath it in case it fell. I don't think that would have happened. Friday the 16th of July, sorry, it's not Friday, but the 16th of July, 1945, at 5 a.m, up it went. This is the only colour photo of the bomb, and it was taken by a photographer who was there on some other project. There was thousands of black and white photos, high-speed photos and all sorts of things, but this is the only colour photo, and he took it unauthorised. But that's the Big Bang. After the explosion, they lead-lined a Sherman tank to drive over ground zero and take some samples. A lot of the byproducts of the explosion have a relatively short half-life. Groves and Oppenheimer here were able to walk in. I wouldn't have, but they did. I walked in 70 years later. It was still mildly radioactive. There's the fallout from it, from the Trinity site, all up this way. And they had all sorts of plans for evacuations if it got bad, and they had a cover story prepared that there'd been a explosion at a ammunition dump on the missile range there, and that was their cover story. The people have asked me about whether they should have actually exploded the bombs over the Hiroshima and Nagasaki. Groves was he was a military man. He was given the job of building the bomb to end the war, and he was going to do it no matter what. So they did. And they were starting to move materials. They flew part of it. They sent some of it by air, some by sea, on the island of Tinian. They got it ready. 6th of August, Hiroshima. 3 days later, was dropped on Nagasaki. And they just had enough plutonium left after the Nagasaki bomb and enough uranium for one more bomb, but that was it. So if they didn't end the war and the Japanese didn't surrender, they would have been hard pressed to go any further. This is a photo after the war of all the tests that were done, 193. These are all atmospheric tests. So the Americans, Kiribati, Johnson Atoll, Marshall Islands, 67 tests in Marshall Islands. The Australians, or well, the British in Australia, Maralinga and Montebello Island, just off the northwest Cape there. There is a video you can find online which shows all the tests chronologically, and it's just a little map. It wouldn't have come up very well on the screen, but it goes blink, 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 as they bombs just go off everywhere. Any wonder the world was covered in radiation. And after the thing, they tried to think of all sorts of purposes for doing tests, all sorts of executions. I'll show you a picture of the Sedan crater. The Russians tried to let off a bomb, make a big crater for a dam beside a river, filled it with water, found it radioactive for some reason. I don't know why. Partial test ground stopped most of it in 1963 and continued on. There's just some photos of the mesa, and up on top of the mesa is Los Alamos, and this is the down the hill, Los Alamos today. This is the Trinity test site. We can walk up, there's a monument there. The sign over here says don't eat food, don't drink, don't apply cosmetics during the while you're on the site, because you might pick up particles of reads the use of eating, chewing, smoking or applying cosmetics is prohibited on this range for risk of picking up radioactive particles. That's it. That's me at the Trinity site. You can't see the sign very well, but that's what it says. Bit of trinitite. After the explosion, they found that the sand, the silica sand under the tower had melted and formed a glass-like substance known as trinitite, which lots of people have taken home. It's still very radioactive, and they put it on their mantelpiece. McDonald's Ranch today, the base camp. I did a tour of the Nevada test site. This, you don't obviously get to see bombs going off these days, but this was the tourist attraction of the time. There's seats everywhere for everyone to sit there and watch the bombs going off. You can't take cameras into the Nevada test site, but they went to underground tests, and you can see the ground is just pockmarked with all these where it's collapsed after things. You've seen photos of the bomb tests and some of the houses that are still there. This is Sedan crater. Again, another test. They were testing everything they could think of, any reason to set off a bomb. This was a bank vault that they decided to see what happens to a bank vault. Let's see what happens when we put soldiers in a trench and let off a bomb nearby, and then get them to get up and march towards the bomb. Just crazy things they did. Further reading, if you want to read The Day the Sun Rose Twice, is very good. Manhattan Project is just ordinary, and now it can be told by Groves himself, is the most complete, and he obviously knew most of everything. Finally, there's some picturing the bomb. There's some good pictures of the bomb, and this was Hanford, and they had that many people there that they were able to form a Girl Scout troop and that sort of thing. And that's basically it. So thank you. We'll see you all next time. Any questions?
Jack just made the observation, Phill, I assume Phil's still there, that in the 90s with some of the balloon launches that were done by the club, I think, Jack, you were saying? Yeah, put a Geiger counter on the balloon that was sent up, and they had a number of indications of radiation because of the French testing. All right, any questions for Phill? No? Okay. Thank you, Phill. Much appreciated for giving up your evening to make the presentation. There's a lot of work that's gone into this this tonight, as evidenced by what you've passed on. So thank you for your presentation. Much appreciated. Right, well that concludes the session for this evening. Please feel free to have a cup of coffee and hang around for a chat. The weather's not too nice outside, but you're more than welcome to hang around for a cuppa and do have a safe trip home after. Thank you.